Hello everyone, my name is Bacem Mbarek. I am a senior researcher at the Faculty of Informatics, Masaryk University in Brno, Czech Republic. Today I am presenting our accepted paper in the ACM SAC 2020 conference. Our paper entitled Enhanced Network Intrusion Detection System for Protocol for Internet of Things, realized by me, by Muzi G and Tomasz Pittner. In this presentation, first I will start by general introduction. I will talk about the IoT security. Second, I will explain our motivation about the intrusion detection system. Then I will explain our solution, which is called Enhanced Network Intrusion Detection System. Then I will explain the results, the obtained results, and I will finish by a conclusion and mention some future directions. Okay, let's start by the general introduction about IoT security. First, what is IoT? The Internet of Things. IoT is the network of physical objects monitored, controlled, and linked over the Internet by a mobile application or software that uses with another platform. IoT security is the technology area concerned with the safeguarding connected devices and networks in the Internet of Things (IoT). During the communication between the different peers in the network, many attacks could appear and could hack many devices and could also insert a lot of forged packets and compromise many nodes. For this reason, a real-time detection of the attacks are critical to protect the IoT networks. The motivation of our paper is to implement an enhanced intrusion detection system. First, let's start to understand the problem of the standard intrusion detection system protocols. We will focus about two type of attacks. First, the clone attack, and the second is the replica attacks. What is clone attack? In this attack, an adversary captures a few nodes, replicates them, and then deploys the replica throughout the network. The problem is these replicas are not detected, the network will be vulnerable to severe internal attack. Uh, an adversary could just create a replica node and insert it in the network. And if also the witness node itself is compromised by this by the same hacker or the same adversary, then the hacker will make this replica node hidden and he will not send any notification to the cluster head or to the other nodes in the network. And how the witness node could detect the replica node? The witness node could compare, for example, the location, the ID, the distance, and if he find that the same information about this node are already recorded its database, then he will detect that this is a replica node. But the problem, if the witness node itself is compromised, then he will not send any notification to the cluster node and to the network nodes. Once an IoT device is compromised, an adversary can launch clone attacks by replicating the compromised node, distributing the clone throughout the network, and starting a variety of inside attacks. In order to tackle the clone attacks, the network intrusion detection systems have been developed to detect the malicious activities such as clone attacks, denial of service attacks, and reply attacks by monitoring the network. Network enhanced intrusion detection system approaches are especially vulnerable to witness compromising attacks, where the adversary can learn the critical witness nodes to start specific attacks and to protect replicas from being detected. Our solution, we propose a new enhanced network intrusion detection system protocol with an efficient replica detection algorithm. A number of replica test nodes are intentionally inserted in the network to test the reliability and response of witness nodes. Here we just create a test node, replica test node, create, and we insert this replica test node near to the witness node, and we will see if this node is will notify the others nodes about it, or it will make it hidden. If it is able to notify the others nodes and detect this replica uh, node, then this witness node is safe. Otherwise, this witness node will be considered as compromised node. The solution is proposed uh, to address the vulnerability of network intrusion detection system and improve the IoT network security to detect the severe compromised attacks, such as the clone attacks. In its protocol is developed to solve the problem of witness compromising attack in IoT networks. And our solution, the user can select the number of witness nodes to be tested. Our solution is composed into algorithm. The first one is the replica test, and the second one is the witness test. For the replica test, we have three inputs: original nodes, and the replica test node, and the witness node. And after signature verification, just we compare the replica node with the original one. We compare the distance, the location, the ID, and many parameters that we can put. And if we find that they are equal, then the test is equal 1, else the test is equal 0. Now for the witness test, we just implement a replica test node, and we will see if this node will be detected or not. If the n replica is equal to n, and the replica test is 0, then there is a problem. We have two nodes equal. They have the same parameters, but the test gives 0. That means the witness node is compromised by an adversary, and the adversary would like to make this node in hidden. Else, if the replica node is equal to the original node and the replica test give 1, then it's good. This is returned that the witness node is safe. Else, if the replica is different to the original and the replica test give 1, they are different, but he gives that there is a uh, replica detection. Means also that this adversary is this node or this witness node is compromised by an adversary. And the last case is if the replica node is different to the original one and the replica test gives 0. This is also good. This is return that this witness node is safe. This is the basic idea of the two algorithms. For the simulation parameters of our solution, it is in order to evaluate the enhanced network intrusion detections protocol, we used the Contiki network simulator, CUJA, to populate security threats and countermeasure the IoT that includes state-of-the-art Svelte protocol and init protocol. The parameter of simulation, we use 100-second simulation time for the simulation area 500 meter. The MAC type is 802.15.4. The runtime is 15 times. The number of nodes is 1000. Mobility, we don't have any mobility. All of nodes have a fixed location. First, let's start with explain the detection probability of replica nodes that we obtained. Here with inits, with our enhanced protocol, we can detect around 95% of the replica node, while only 50% are detected with Svelte. And could be explained by the fact that order in order to detect more replica nodes, we use the test node to verify the witness node performance, and each node in the network is able to generate and transmit replica tests to verify the witness node performance. But with this Svelte protocol, it is not enabled to detect the witness compromising attacks. For this, we have a very high probability of detection of attacks, of witness compromising attack and replica nodes attack. For the energy consumption, uh, init consumes slightly more energy in the absence of attacks, and it consumes significantly less energy in the presence of attacks. in it detects more cloned nodes, which protects the routing operations against the reforwarding of messages to the unreachable nodes in the network affected by cloning attacks. While with this Svelte, an adversary can compromise a node and inject cloned nodes without being detected. As you see, like with our solution, the uh, replica nodes are detected, and if they are detected, they will be removed from the network. But with this Svelte protocol, they couldn't be detected, and this they will send a forged packet and forged message in the network, and this is for this reason their consumption will be very high, and will also affect all of the security of the network. Conclusion. In this paper, we have proposed an init protocol with a replica detection algorithm to detect the clone attacks in IoT networks. The replica detection algorithm is based on the insertion of a test replica nodes and uses the reaction of the witness node to justify if the witness node is compromised or not. In the simulation, a replica test is created and assign it to a randomly witness node in the IoT network to enforce security by identifying potential malicious node. As a future direction work, we plan to add more experiments with other needs protocols, and we can compare our solution with many others protocol, and we will extend and improve our solution to detect and discover others attack in the IoT networks. Also, we plan to deploy needs for a real-world IoT network and consolidate the performance of the proposed authentication algorithm. Also, the societal and economic concerns can be reduced due to the security issues in smart IoT application. We can also use our enhanced protocol in many applications such as smart city, smart home, vehicular network, routing protocols in many domains. That is all from my side, and thank you for your attention. And you are welcome if you have any questions. Thank you.